In the mid-60s, Ferrari ruled Le Mans with an iron fist, and Enzo Ferrari himself believed no American engine could touch his finely tuned machines. Then came a single moment that changed everything. An insult so devastating, it sparked the most personal feud in motorsport history. That moment of arrogance gave birth to one of the most legendary engines ever created, the Ford 427 side oiler. And when it roared to life at Le Mans in 1966, history was rewritten forever. This is the story of the engine that silenced Enzo Ferrari. The year was 1963, and Henry Ford II had a problem. Ford's sales were strong, but the company's image was boring. While Ferrari dominated racetracks across Europe, Ford was known for practical family cars and pickup trucks. The solution seemed simple: buy Ferrari and instantly acquire decades of racing prestige. Ford's team flew to Modena with checkbooks ready. The negotiations went smoothly, almost suspiciously so. Enzo Ferrari agreed to sell his company for $18 million, roughly $180 million in today's money. The contracts were drafted, hands were shaken, and Ford executives started planning their European racing campaign. Then Ferrari dropped his bombshell. 3 days before the final signing, Ferrari backed out. But he didn't just cancel the deal. He humiliated Ford in the process. Ferrari told the press that he would never allow those people from Detroit to control his racing decisions. He called Ford's executives ugly Americans who knew nothing about racing. The insult that stung most was Ferrari's claim that Ford built ugly little cars for ugly little people. Henry Ford II read those quotes over breakfast at his Grosse Pointe mansion. The grandson of the company founder wasn't known for his temper, but this attack was personal. Ford had offered Ferrari financial security and global resources, only to be dismissed as inferior. The slight cut deep because Ford knew Ferrari was right about one thing. In 1963, Ferrari's racing reputation far exceeded Ford's. Lee Iacocca, Ford's rising star executive, saw opportunity in his boss's anger. During a heated meeting at Ford headquarters, Iacocca proposed something radical: beat Ferrari at their own game. Rather than buying racing credibility, Ford would earn it by building better cars and faster engines than anything coming out of Maranello. The board meeting where Ford approved Project Fairlane lasted 6 hours. Ford committed $7 million to develop a racing program capable of winning the 24 Hours of Le Mans within 3 years. The budget was unprecedented for an American manufacturer entering European racing. Ford's executives understood they were declaring war on the most successful racing constructor in history. Ferrari had won Le Mans 6 consecutive times from 1960 through 1965. Their 250 LM and 275P models dominated endurance racing with a combination of lightweight construction, sophisticated aerodynamics, and bulletproof reliability. Ferrari's V12 engines produced around 320 horsepower, while weighing significantly less than comparable American V8s. Most importantly, Ferrari understood Le Mans like no other constructor. They knew that winning required more than raw power. Cars had to survive 24 hours at racing speeds while maintaining perfect mechanical precision. So, Ford's challenge was enormous. They had never built a purpose-designed race car. Their only racing experience came from NASCAR ovals, where durability mattered less than peak horsepower. European racing demanded different skills: aerodynamic efficiency, lightweight construction, and engines capable of sustained high RPM operation for hours without failure. The Advanced Vehicles Division was established in Dearborn with one mandate: create whatever was necessary to beat Ferrari. Roy Lunn, a British engineer with sports car experience, was hired to lead the project. His first decision was controversial. Rather than building everything in Detroit, Ford would partner with established European racing specialists. Lola Cars in England would handle chassis development, while Ford's engineers focused on creating an engine powerful enough to overcome any aerodynamic disadvantages. Ford's revenge plan required more than good intentions and unlimited budgets. They needed an engine that could match Ferrari's sophisticated V12s, while providing the reliability American engineering was famous for. The existing 390 FE engine was a starting point, but circle track racing had already revealed its limitations at sustained high RPM. Ford's engineers knew they were designing more than just another racing engine. They were creating the weapon that would silence Enzo Ferrari's mockery once and for all. Ford's engineering team gathered at the Dearborn test facility in late 1963 with ambitious goals and tight deadlines. The FE series Fawn 8 had evolved through 6 generations since 1958, growing from the original 332 cubic inch displacement to the 390, then briefly to the 406. Each iteration taught Ford's engineers valuable lessons about high-performance engine design, but none prepared them for the demands of 24-hour endurance racing. The decision to create a 427 cubic inch engine came from racing regulations rather than engineering preferences. Most major racing series limited displacement to 427 cubic inches, so Ford rounded up their actual 425 cubic inch displacement to match competitors like Chevrolet's 427 Big Block. The marketing department loved the symmetry. 427s sounded more impressive than 425s, especially when competing against GM's engines in showroom battles. Ford's engineers took the proven 3.78-inch stroke from the 390 engine and paired it with a massive 4.2 3-inch bore. This combination prioritized high RPM capability over low-end torque, exactly what endurance racing demanded. The compression ratio jumped to 12.5 to 1, requiring premium fuel but delivering significant power increases. Early dyno tests showed promise. The 427 produced 425 horsepower in street trim and over 500 horsepower in race configuration. The engine's foundation required extensive strengthening for racing applications. Ford specified high nickel iron alloy for the block, adding weight but providing crucial durability under sustained stress. The cylinder walls used a cloverleaf design that was significantly thicker than production engines. Crankshaft crossbolts secured the main bearing caps, while enlarged main bearing webs distributed loads more effectively. Starting in 1965, Ford switched to forged crankshafts for maximum strength. Initial testing revealed the 427's impressive power output, but also exposed a fatal flaw. The early engines used a top oiler system inherited from previous FE designs. Oil pressure from the main pump fed the valve train components first, then traveled down to lubricate the crankshaft bearings. This priority system worked perfectly for street driving and even moderate racing, but failed catastrophically under sustained high RPM operation. NASCAR testing at Daytona provided the first warning signs. During practice sessions exceeding 5,000 RPM for extended periods, multiple 427 engines suffered bearing failures. The pattern was consistent. Crankshaft bearings would lose oil pressure and seize, destroying the engine instantly. Ford's racing hopes were literally grinding to a halt on the banking at Daytona. Circle track competition revealed the problem's scope. At Michigan International Speedway, 3 Ford test cars retired with identical bearing failures during a single afternoon. The engines were producing tremendous power, but the oiling system couldn't maintain adequate lubrication to the most critical components during sustained high-speed operation. Ford's engineers realized they faced a fundamental design flaw that threatened the entire racing program. The solution required completely rethinking oil flow priorities. Led by Chief Engineer Bill Gay, Ford's team designed an entirely new oiling system that reversed traditional priorities. Instead of feeding the valve train first, the new side oiler design sent pressurized oil directly to the crankshaft bearings through a dedicated passage along the left side of the engine block. This modification created the visual signature that gave the engine its famous name. A raised ridge along the engine's left side housed the new oil gallery, making side oiler engines instantly recognizable. The system ensured that crankshaft bearings received oil before any other engine component, guaranteeing lubrication even under the most extreme racing conditions. The engineering change was relatively simple in concept, but revolutionary in execution. Oil pressure from the main pump now traveled through the side gallery directly to the crankshaft bearings, then continued to the valve train components. This priority system meant that even if oil pressure dropped slightly during hard cornering or sustained high G operation, the most critical engine components remained properly lubricated. Testing results from the revised side oiler design were immediately impressive. The same engines that had failed at Daytona now ran flawlessly for hours at maximum RPM. Dyno testing showed the side oiler could maintain peak power output for extended periods without any decrease in oil pressure to critical components. Ford had solved their reliability problem while maintaining the engine's impressive power output. The 427 side oiler's specifications were impressive by any standard. Street versions produced 425 horsepower with dual quad carburetors or 410 horsepower in single carburetor configuration. Torque output reached 480 pound-feet, providing strong acceleration across the entire RPM range. Racing versions with high-riser heads and specialized intake manifolds exceeded 500 horsepower while maintaining the bulletproof reliability that endurance racing demanded. Ford had created their weapon, but they were about to take engine development to extremes that would shock even their own engineers. By early 1965, Ford's 427 side oiler was proving competitive, but Henry Ford II wanted absolute domination. The standard side oiler produced impressive power, but Ford's engineers believed they could extract significantly more performance through advanced valve train technology. What they created became known as the Cammer, an engine so powerful it was banned before it ever competed. The 427 SOHC project began with a simple question: how much power could Ford extract from 427 cubic inches? The answer required abandoning traditional pushrod valve actuation in favor of single overhead camshafts, a technology more common in European racing engines. Ford's engineers studied the latest Formula One and sports car designs, then adapted overhead cam technology to their massive American V8. The development timeline was incredibly aggressive, earning the engine its 90-day wonder nickname. From initial concept to running prototype took exactly 90 days, a pace that would be impossible with modern development requirements. Ford assigned their best engineers to the project while maintaining absolute secrecy. Even within Ford, only a handful of people knew about the Cammer's existence until testing began. The overhead cam system required extensive modifications to the basic 427 architecture. Each cylinder bank received its own camshaft mounted directly above the valves, eliminating push rods, rocker arms, and the associated mechanical losses. The camshafts were driven by a single 7-foot-long roller chain that connected both overhead cams to the crankshaft. This chain system was unique in American automotive engineering and required precise manufacturing tolerances to function reliably. Combustion chamber design borrowed heavily from Chrysler's successful 426 Hemi. The Cammer featured hemispherical combustion chambers that allowed larger valves and more efficient airflow than traditional wedge-shaped chambers. Combined with the overhead cam system's ability to operate larger camshaft profiles, the Cammer could move dramatically more air than any other American engine. Initial dyno testing revealed the Cammer's incredible potential. With a single 4-barrel carburetor, the engine produced 616 horsepower and 515 pound-feet of torque. These numbers were conservative. Ford's test engines actually produced closer to 650 horsepower, but official ratings were kept lower for strategic reasons. With dual 4-barrel carburetors, power output exceeded 700 horsepower, figures that seemed impossible for a naturally aspirated engine in 1965. NASCAR officials learned about the Cammer through industry contacts and immediately demanded specifications. When Ford submitted technical drawings showing an overhead cam V8 producing over 600 horsepower, NASCAR's reaction was swift and decisive. The sanctioning body had spent years trying to control escalating power levels, and the Cammer represented exactly the kind of special racing engine they wanted to prevent. The controversy reached its peak during NASCAR's annual rules meeting in December 1965. Ford representatives argued that the Cammer was simply an advanced version of their existing 427 engine, which was already legal for competition. NASCAR countered that overhead cam technology represented a fundamental departure from traditional American push-rod engines and would create an unfair competitive advantage. NASCAR's compromise proposal was deliberately punitive. The Cammer would be legal for competition, but only if Ford teams accepted a 430-pound weight penalty that would bring total vehicle weight to 4,400 pounds. Comparable Dodge and Plymouth race cars weighed approximately 3,970 pounds, meaning Ford teams would carry nearly 11% more weight while producing significantly more power. The weight penalty was calculated to eliminate any performance advantage the camera might provide. Ford's racing teams examined NASCAR's proposal and quickly realized it was unworkable. The additional 430 pounds would be added as ballast in the worst possible locations, raising the center of gravity and destroying handling balance. More importantly, the extra weight would increase tire wear and brake system stress during 500-mile races. No team accepted NASCAR's offer, effectively banning the camera from stock car competition. The NHRA welcomed Ford's new engine with enthusiasm. Drag racing's quarter-mile format was perfect for the camera's explosive power delivery, and sanctioning bodies were generally more permissive about advanced technology. Ford shipped camera parts to their drag racing partners, who immediately began setting records. Funny car applications pushed camera output to extraordinary levels. Drag racing specialists like Pete Robinson and Connie Kalitta extracted over 2,500 horsepower from heavily modified camera engines using exotic fuel mixtures and radical compression ratios. These extreme builds typically lasted only a few runs before requiring complete rebuilds, but their performance was spectacular enough to justify the maintenance costs. The camera's production numbers were extremely limited. Ford built fewer than 500 complete engines, with most going to drag racers or serious collectors. Today, original camera engines sell for $65,000 or more, making them among the most valuable Ford engines ever produced. Even non-running cores command premium prices from collectors who understand their historical significance. Ford officially discontinued camera development, focusing resources on their successful Le Mans program instead. The 1966 24 Hours of Le Mans began on June 18 with perfect weather and massive anticipation. Ford arrived at the Circuit de la Sarthe with 8 GT40 Mark II race cars, each powered by the 427 side-oiler engine. Ferrari brought just 3 P3 prototypes, confident that their lightweight design and superior aerodynamics would overcome Ford's raw power advantage. What happened over the next 24 hours changed motorsport history forever. Ford's preparation for Le Mans 1966 was unlike anything previously seen in endurance racing. The company spent over $9 million developing the GT40 program, equivalent to roughly $85 million today. Every component was tested extensively at Ford's Dearborn facilities and European test tracks. The 427 side-oiler engines underwent thousands of hours of dyno testing to ensure they could maintain peak performance throughout the race's duration. The GT40 Mark II represented Ford's most advanced racing technology. The fiberglass body was designed in Ford's wind tunnel to achieve maximum straight-line speed while maintaining stability at over 200 miles per hour. The chassis used advanced aluminum construction that was both lighter and stronger than traditional steel tube frames. Most importantly, the 427 side-oiler engine was tuned to produce 485 horsepower while maintaining absolute reliability. Ferrari's strategy relied on their traditional advantages: lighter weight, superior fuel economy, and tactical excellence. The P3 prototype weighed approximately 200 pounds less than the GT40 while achieving better fuel mileage. Ferrari's engineers calculated that their cars would require fewer pit stops, potentially offsetting Ford's speed advantage through superior race strategy. This approach had worked successfully for 6 consecutive Le Mans victories. Practice sessions revealed Ford's stunning speed advantage. Dan Gurney's GT40 recorded the fastest lap in practice at 3 minutes, 30.6 seconds, nearly 4 seconds faster than the quickest Ferrari. More impressive was the consistency. All 8 Ford entries lapped within 2 seconds of each other, demonstrating the 427 side-oiler's reliability and the GT40's predictable handling characteristics. The Mulsanne Straight became Ford's killing ground. GT40 Alsace reached speeds exceeding 218 miles per hour compared to Ferrari's maximum of approximately 205 miles per hour. This 13 miles per hour advantage meant Ford cars could make up significant time on every lap, even if Ferrari held small advantages through the technical sections. The psychological impact on Ferrari drivers was enormous. They could hear the Ford engines approaching from hundreds of yards away. Ferrari's race began disastrously. Within the first 2 hours, mechanical problems eliminated one P3 prototype. The remaining Ferrari entries were fast enough to stay competitive during the early stages, but the sustained high-speed running began exposing reliability issues. Ferrari's lightweight construction, optimized for previous Le Mans victories, couldn't handle the increased pace Ford was setting. Ford's race strategy was deliberately conservative. Rather than pushing for maximum speed, Ford teams maintained consistent lap times that gradually built an insurmountable lead. The 427 side-oiler engines ran flawlessly, maintaining oil pressure and operating temperatures throughout the most demanding sections of the circuit. This reliability allowed Ford to maintain their pace while Ferrari struggled with overheating and mechanical problems. By midnight, Ford held the top three positions with comfortable margins over the surviving Ferrari entries. The side-oiler engines had proven their durability. None of the Ford entries experienced any engine-related problems during the race's most critical period. Meanwhile, Ferrari's remaining P3 cars were falling behind as their engines began showing signs of stress from trying to match Ford's pace. The race's final stages became a Ford procession. Ken Miles in the leading GT40 was instructed to slow down and allow his teammates to catch up for a dramatic photo finish. This decision would later become controversial when race officials determined that Bruce McLaren's GT40 had actually won due to starting further back on the grid. But the message to Ferrari was clear. Ford had speed to spare. Ferrari's humiliation was complete when their final P3 retired with engine failure in the 20th hour. None of Ferrari's three entries finished the race, marking the first time since 1959 that Ferrari failed to place a single car on the podium at Le Mans. The Italian team's 6-year winning streak was over, ended by American engineering and unlimited determination. The final results showed Ford's dominance beyond any doubt. Ford GT40s finished first, second, and third, with the winning car averaging 125.4 miles per hour for the entire 24-hour duration. The 427 side-oiler engines completed the race without any significant mechanical issues, proving that American engineering could match European sophistication when properly applied. Henry Ford II's presence at the victory celebration was deeply personal. The man who had been insulted and humiliated by Enzo Ferrari 3 years earlier watched as his cars dominated the world's most prestigious race. Ford's victory was more than just a racing success. It was proof that American industrial might could succeed in any arena when properly motivated. The psychological impact on Ferrari was devastating. Enzo Ferrari, who had mocked Ford's ugly little cars for ugly little people, watched his racing empire crumble in a single afternoon. The Italian press described the result as a national humiliation, while American media celebrated Ford's triumph as proof of American engineering superiority. Ford's 1966 Le Mans victory was just the beginning. The 427 side-oiler engine would continue winning races and breaking hearts, creating a legacy that endures today. Ford's 1966 Le Mans victory was spectacular, but the 427 side-oiler's dominance was just beginning. Over the following 3 years, Ford GT40s powered by the side-oiler engine would win Le Mans 4 consecutive times, establishing American engineering credibility in European motorsport. The engine's influence extended far beyond racing, transforming Ford's performance image and inspiring generations of automotive enthusiasts. The 1967 Le Mans victory was perhaps even more impressive than the previous year's breakthrough. Dan Gurney and A.J. Foyt drove their GT40 Mark IV to victory, averaging 135.48 miles per hour and setting a new distance record that would stand for 24 years. The Mark IV was the most advanced GT40 variant, featuring improved aerodynamics and a specially tuned 427 side-oiler, producing over 500 horsepower. Ferrari's attempts at revenge failed completely. Their new P4 prototypes were fast but unreliable, allowing Ford to dominate once again. The side-oiler's versatility became apparent as it found success in multiple racing disciplines. NASCAR teams began adopting the engine for superspeedway competition, where its high RPM reliability provided significant advantages during 500-mile races. The engine's ability to maintain power output for extended periods made it ideal for endurance racing, while its impressive peak horsepower satisfied drag racers seeking maximum quarter-mile performance. The 427 side-oiler's production run was relatively brief but highly influential. Ford built the engine from 1965 through 1968, with total production estimated at fewer than 20,000 units across all applications. Street versions were available in various Ford and Mercury models, but high manufacturing costs limited widespread adoption. Most buyers chose less expensive alternatives like the 390 or 428 engines that provided similar performance at lower cost. Ford's decision to discontinue the side oiler reflected changing market conditions and internal priorities. The 428 Cobra jet engine, introduced in 1968, produced similar power at significantly lower cost, while new emissions regulations made high-compression engines increasingly problematic. The 385 series big block engines provided a more cost-effective foundation for future performance applications. Modern collector markets have vindicated the 427 side oiler's legendary status. Original Dower 27 Cobras regularly sell for over $750,000, regardless of condition, with exceptional examples exceeding $1 million. GT40 replicas powered by authentic side oiler engines command premium prices from collectors who understand the historical significance. Even non-running 427 engines sell for $15,000 to $25,000, reflecting their rarity and desirability. Restoration specialists who work on original 427 engines report that properly maintained examples can still produce impressive power after nearly 60 years. The engine's robust construction and conservative design parameters mean that many survive in excellent condition despite decades of use. Professional rebuilds can restore full power output while maintaining the engine's original character and reliability. Today's automotive landscape is dominated by turbocharged engines, hybrid systems, and electric powertrains. But the 427 side oiler's legacy endures. The engine proved that American manufacturers could compete successfully against established European rivals when properly motivated and adequately funded. More importantly, it demonstrated that innovative engineering solutions could overcome seemingly insurmountable competitive disadvantages through clever design and relentless development. So, what do you think of Ford's legendary clapback? Drop your thoughts in the comments and don't forget to hit the like button and subscribe for more legendary automotive stories like this. Until next time, thanks for watching.